Joseph runs a marathon, and his dad gives him $2 for every mile he runs. His aunt gives him $5 to start, but she will double the amount every mile. He ran 10 miles, and how much does he get for each plan and the total?
As you can see, this is for the dad's plan. The dad adds $2 for each time that Joseph runs the mile. So adding 2 each time, it goes 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, up to 20, which is at the 10th mile.
The recursive rule is next equals now plus 2, and the start is 0. The explicit form is y equals x times 2, right? Yeah. Predictions. If I ran 13 miles, I would receive $26. So y equals 2 times 13, and then the y equals 26, because you would take the 2, which is the amount that you add, and then 13 miles. So for every mile, you get $2, and then you get 26. For my second prediction, if I ran 20 miles, I would receive $40. So you would take the $2 and multiply it by the 20 miles, and you would get $40.
For our exponential growth plan, hold on. Okay. His aunt gives him $5 to start with, but she will double the amount for every mile that Joseph runs. So he ran 10 miles, meaning that the Y column would be the money and the X column would be the miles. The miles would go up to 10, and the X column would go, and the Y column would go up to the amount that reaches the 10th Y value. Okay, and the recursive rule is next equals now times 2, with the start being 5. The explicit rule is y equals 5 to the second to the power 5 times 2 to the power of x. As for my predictions, if Joseph runs 11 miles, he would get $10,240. This is because if you go to the 11th x value and you put 11 into the formula, which would be y equals 5 times 2 to the power of 11, you get the value of 10,240. For my second prediction, if Joseph got $327,680, he would have had to run 16 miles. This is because if you go into the graph of your calculator using the formula, you would find in the graph, in the table, that at the 16th x value, the y value would be 327,680.
Did you put your predictions for this one?
No.
Okay. You have to put your regressive and explosive form, and then predictions was the page right after. Are you guys even half done yet?
No.
I mean, recording isn't going to take that long, right?
We have 9 minutes.
Apparently not. Apparently it is. I keep on hearing that you have to start over.
You keep starting over like no reason. Wait, which one is this? Okay, this is for Joseph's job.
Linear decay.
Say what?
Linear decay.
Yeah. Yeah.
First you have to put your equations in explicit forms, and you could do that last minute.
There we are. Use photo. Image, okay. Okay, done.
But you still have to put the explicit in. Just put it right there.
Okay. Now,
Whose pencil is this?
mine. My recursive for this linear decay.
Did you correct it?
Yeah.
I thought trillion was
We're not gonna have leopard time to do it.
Yeah. Because of his spending habits and missing work, Joseph's hourly pay is $15. But for every day he misses work, he loses $2 off of his hourly pay. To create the table, you have to use a specific formula. The formula being next equals now minus 2, subtracting 2 for each y value. Because now the recursive is next equals now minus 2 with the start of 15. The explicit rule is y equals negative 2 times x plus 15.
Days is because the amount of days he missed.
The days, which is the x value, is up to 5 because that is the maximum amount of days he missed before he went back to work. For my predictions, if he is getting $1, he has missed 7 days. You can figure this out by plugging in the numbers into the formula. 1, replacing the y, 1 equals negative 2x plus 15. You solve this as a regular formula. Subtracting minus 15, you get negative 14 equals negative 2 times x. Divide by negative 2 on each side, and you get 7 equals x. If he misses 6 days, he will have $3 an hour as his hourly pay. You can figure this out by also plugging in the numbers. Y equals negative 2 times 6 plus 15. Adding all this together will equal 3.
To record, just press this little button and go through our slide.
Check your answers. Week 10,
You're gonna be
you run
so random, that you talk all
you run 50 miles. Please.
Joseph puts the money in a bank and he puts $5,140. He spends 20% of the money each year. So, for the table, he is multiplying it by 0.80, which is 80%, and the recursive problem is next equals now times 0.80, and the explicit form is 5,140 in parentheses 1 minus 0.20, which is the percent, and then to the x power. For my predictions, the first one would be, in 8 years, Joseph will have $862.35 left in his savings. So you would get this by plugging in the 8 years for the exponent, and it would look like 5,140 parentheses 1 minus 0.20, which is the percent that he uses every year or spends every year, to the 8th power. And you will get this, and your answer would be 862.35. For my second prediction, it states, in 10 years, Joseph would have spent $4,588.09. So the way you would get this is by taking your explicit problem, and adding in the 10 for the exponent, and then you would multiply it all, and you get 551 and 91 cents. But the problem says, or prediction says, that in 10 years he would have spent. So you would subtract 551 from 5,140, and you would get 4,588 and 9 cents.